Our content will be divided into 4 parts, and I will cover the first part, project description and overview. I'm sure everyone has heard of the company Tesla. Tesla was founded in 2003 in California with the goal of developing and producing high-performance electric vehicles. In 2004, Elon Musk became the company's primary investor and the chairman of the board, gradually emerging as a central figure and CEO. The company went public on the Nasdaq in 2010, and as of November 2024, it has a total market capitalization of 1.11 trillion US dollars. So we are going to focus on 3 main goals. Analyze Tesla's current operating status and review its market performance over the past few years. And then we will focus on automotive sales and analyze Tesla's sales performance over the last few years. Finally, we use Excel and Python to build 3 models in an attempt to predict future sales. All data in this article is real. Financial data comes from the company's annual reports, while sales data is resourced from Kaggle database. In our predictions, we also make several assumptions. We emphasize the trends within the data itself and predict future sales from the perspective of historical data. This means we did not directly focus on explanatory variables such as customer income or government policies, but rather conduct a black box analysis based on sales trends from the past few years. Let's start it by reviewing Tesla's performance. The first 2 images shows Tesla's operational revenue and net profit from 2009 to 2023, along with their growth rates. Due to the significant R&D and infrastructure investments needed in the early stage of electric vehicles, Tesla only reported positive net profit starting in about 2020. The next image highlights the source of Tesla's automotive revenue, with over 85% coming from the vehicle sales. This is one of the reasons we are focusing on sales forecasting, because it's crucial. The next 3 images illustrate the market development in the electric vehicle industry. The first image lists several countries and their projected percentage of electric vehicle adoption. And the second image shows that from 2012 to 2023, electric vehicle sales skyrocketed by about 1,000 times, which is an incredible growth rate. Yeah. A third image displays the market share of electric vehicles within the automotive industry, reaching nearly 18% in 2003. The following 2 images provide a global perspective, showing that Tesla's performance remains strong. This image compares Tesla to three companies from China, electric vehicle companies. Yeah. Tesla has the highest average selling price and also shows solid gross profit.
Hello everyone, my name is Jin Yang, and I will bring you the first half of our part 2. You can see, just like the big title shows, our part 2 is about the descriptive analysis of Tesla. First of all, we collected a dataset relevant to the electric car market in Washington State in the website Cargo. The reason why we choose this dataset is because it counted the number of electric vehicles registered from the 1997 to 2024, so it is comprehensiveness. And the second reason is reliable. This dataset was counted based on the information from the US government. And next section, we do the research on the overall trends on the electric vehicle market in Washington State. Table 1 shows the production year from 1997 to 2023, and the production quantity, which was screened out by the pivot table function in Excel. And table 2 is the visualization result of table 1 by presenting as a line chart, and we can see that from 1997 to 2023, the overall trends of electric vehicle ownership in Washington State is rising, especially after 2011. More and more people began to buy electric vehicles, and the line also increased rapidly. Let's turn our attention to the details, which is about the Tesla performance in electric vehicle market in the Washington State. In step 1, we do the preparation for research. We inputted the necessary libraries such as Panda, NumPy, and Seaborn, and loaded the dataset. And then we cleaned the dataset to ensure the validity of all the data. In the previous observation, we found that 2011 is the beginning year of rapid growth of overall sales volume in electric vehicle market. So we mainly select the data between 2011 to 2023 for analysis. The second step is exploratory data analysis. We counted the total sales of the top 10 brands. It is not difficult to see that between 2011 and 2023, Tesla's overall sales had an overwhelming advantage, far higher than the total sales of other brands, and ranked first in the top 10. Then we counted the top 10 sales models of these brands. We can find that there are 4 models of Tesla in the top 10. Among them, Tesla's relevantly cheap models, Model 3 and Model Y, occupied the first and second positions, with a difference of about 10,000 vehicles. And compared with the Nissan Leaf, which ranked third, Tesla had a cliff-like leading advantage. The third step is using Python to do a pivot table. We made a detailed analysis of the annual sales of top 10 brands and made a line chart to visualize the sales trends of each brand every year. Since Tesla has a clear lead, for the sake of the beauty of the line chart, the sales volume is calculated logarithmically. Here I gave 3 important time stages. The first one is before 2015. It is found that Tesla did not pull away from other brands. And in 2017, Tesla was overtaken by Chevrolet on sales. And after 2018, Tesla's total sales were far ahead of other competitors. On this slide, the figures not only shows the development trends of Tesla itself vertically, but also compare the sales of Tesla and other car brands in different ways horizontally. This shows that Tesla has not only made significant progress on its own, but also occupied a clear advantage position in competition with other brands. Before I finish my part, I want to ask a question. Why Tesla can build such a big lead over their car manufacturers? And my partner will explain the reason next. Thank you.
Next, I'm going to explain why Tesla can build such a big lead over other car manufacturers. The reasons can be expanded from the following aspects. First, it's because of its technological innovation. In terms of battery technology, Tesla's 21,700 lithium-ion battery has a higher energy density than other manufacturers' products, which means that the same volume of Tesla vehicles will have a longer driving range. In addition, Tesla's V3 supercharging pail can achieve up to 2050 kilowatts of charging power, significantly reducing charging time and improving the user experience. In contrast, many other brands have lower charging power, resulting in user inconvenience. As for autonomous driving technology, Tesla's autopilot and full automatic driving functions are one of the highlights. By constantly updating the software, Tesla vehicles are able to achieve more autonomous driving functions. Tesla's software ecosystem is also a big plus. The vehicle is equipped with a powerful software system that enables users to receive new features and performance enhancements via OTA updates, keeping the vehicle up to date and increasing customer satisfaction and loyalty. The second advantage is its marketing strategies. Tesla have adopted a direct sales model by passing the traditional dealer network and selling vehicles directly to consumers. This not only reduces costs but also enhances the interactive experience for consumers. Tesla's brand image is positioned in the high-end and technology-oriented. Simple and stylish design and full of technological sense of the interior attracts the pursuit of innovation consumers, especially the younger generation. Tesla values the users' community and enhance users' engagement through social media and offline events. Owners often organize events on their own to share experience and provide feedback, and these close-knit communities of users not only increase brand loyalty but also provides valuable suggestions for product improvements. Tesla's owners tend to be loyal fans of the brand, actively recommending the products through social media and word of mouth, attracting a large number of new users. Third is its production and supply chain advantages. Once fully operational, Tesla's new plant in Texas will be the largest electric vehicle production site in the United States, significantly increasing production capacity, reducing transportation costs, and speeding up market response. In the face of global chip shortages and rising raw material prices, Teslas have ensured the stability of productions and demonstrated flexible supply chain management capabilities by diversifying its supply chain and strengthening cooperations with suppliers. To conclude this part, in Washington state, electric vehicles have gradually increased in sales since their development, becoming the choice of more and more people. Tesla not only ranks first in total sales, but also ranks among the best in various vehicle models, which cannot be separated from Tesla's accumulated technical precipitation and excellent marketing model.
And this part is about sales forecast. And first is data collection. Our raw data consists of a mixed panel dataset. including sales figures for various car models in Washington state from 2012 to 2023, and the company's quarterly EV deliveries data from 2015 to quarter 3 2024 in USA. Then, by analyzing historical data, we aim to focus Tesla's sales for the coming years and conduct a preliminary analysis to better get business decisions. After data cleaning, we selected 3 methods: exponential smoothing method, Riemann method, and profit method. We choose these methods based on the characteristics of the data and our forecasting requirements. To use this method, first we need to choose the smoothing constant alpha. In this study, alpha's value range is determined by empirical judgment for different vehicle models time series. Several alpha values are tested, and one with the smallest prediction error is chosen as the final smoothing constant. Then we need to establish a prediction model. In data prediction, we started with the initial values, and then use the forecast formula in Excel to calculate the subsequent forecast values step by step. And then we obtain the sales data forecast for the Model 3, Model S, Model X, and Model Y in Washington state in 2024, as shown in the table below.
Hi, I'm Liu Jiayi, and I'm going to show you the forecasting part 2. In this section, we are still going to use the exponential smoothing forecasting method to do a prediction for Tesla's EV sales for quarter 4 in 2024. And all data is collected from the investor relations section in Tesla's official website. And we're going to do the forecasting step by step. First, we'll estimate for a seasonal factor, and then we will compute the forecast. And third, we'll determine the initial value, smoothing constant, and the final forecast. To estimate for seasonal factor, first, we need to calculate the averages for all deliveries in each quarter, like we can see from the graph on the right. And second, we will calculate the overall average based on quarterly average. Third, we will estimate seasonal factors, which equals to the quarterly average divided by the overall average. To compute the forecast, first we need to remove the effect of seasonal patterns, which is to divide the actual deliveries data by the according seasonal factors. Then we need to apply the exponential smoothing method to get the seasonally adjusted forecast. Finally, we will apply the according seasonal factors to compute the actual forecast, considering the seasonal trends. To determine the initial value, smoothing constant, and final forecast, we need to first calculate the MSE, which is the sum of square of the forecasting errors divided by the total number of forecasts. And leveraging Excel solver, we will resolve the smoothing constant and the initial value, which minimize the MSE. And here, let's do a result and method limitations evaluation. The smoothing constant is 0.92964995, which is relatively large, and this large value indicates that the conditions are fluctuating, that more recent data should be valued more compared to the older ones. Plus, we have to mention that deliveries data cannot fully describe sales, that because factors like leasing contracts and logistics performances cannot be overlooked. The extremely large MSE and MAD showcase the inescapable errors, indicating the limitations of the exponential smoothing model we use here. And reasons behind might be some Tesla EVs were launched in recent years, resulting in insufficient datasets for the model to learn the underlying patterns and yielding accurate results. Moreover, significant volatility exists in the dataset that the model might fail to learn to capture these characteristics. Next, let's move to the Riemann model part. First, I will introduce you some basic concepts. The Riemann model effectively analyzes datasets with time series feature by combining autoregression and moving averages, addressing non-stationarity through differencing. Considering Tesla's sales correlation with past performance and its upward trend, employing the Riemann model to conduct forecasting is well justified to capture these dynamics accurately. For its implementation with Python, the built-in stats model libraries of Python include uniroot testing and ARIMA, which could assist in further model prediction and stationarity test. Hence, Python is chosen for Tesla EV sales forecasting to ensure the comprehensiveness. Next, I will introduce the develop process. First, we need to set the model. The forecasting period is set to 5 years, and the functions include stationarity check, ADF testing, and model fitting. The parameters for the ARIMA model include the order of autoregression, the degree of differencing, and the order of moving average, initially all set to default value of 1, and the output results stored in a variable name forecast. For model application, the model is applied to different Tesla EVs, and the results are converted into a data frame for further visualization analysis. For results interpretation, the ADF test results and the forecast for 4 types of Tesla EVs, which are Model S, Model X, Model 3, and Model Y, are shown. The p-values determine whether to reject the null hypothesis. For example, Model X has passed the ADF test, confirming that the data is stationary. However, for Model Y, the data has excessive volatility, probably due to the insufficient dataset that the Model Y has just been launched for 3 years. The forecasts are visualized with different colored lines representing different EV types, and the purple one demonstrating the total sales forecast. The forecasts for Model S and Model X are believed to be relatively accurate, and the substantial drops in sales in 2023 might be sourced into the intensified industry competition, with more brands and products enter the market. Although the NEV market is fast, the upward trend may not be sustained indefinitely, especially for durable products like automobiles. Moreover, an evaluation about the ARIMA model's limitations has been conducted. The ARIMA model indeed leverages all historical data as much as possible, which is theoretically feasible based on prior analysis. However, issues like insufficient sample size and unexpected black swan events, like the factory fires and geopolitical tensions, can lead to the fact that the forecast might deviate from the actual values.
And the first method we use is Profit method. Profit divides forecast into trend, seasonality, holiday effects, and white noise, facilitating detailed analysis. Its modular approach helps identify forecasting challenges. And the first step is function definition. Profit requires that the date column be labeled as DS and the target value column as Y, so we need to transpose the original data accordingly. Then we use the built-in functions of the Profit library to generate forecast, returning the predicted values. And the next step is model application. We iterate through each car model to make predictions, storing the results in a dictionary. Finally, we convert this dictionary into a data frame for easier visualization and analysis. Here's the results and interpretation. Figure 20 displays the predicted values, while Figure 21 shows the visualization of this forecast. Compared to the previous 2 methods, Profit's predictions are more optimistic, showing an upward trend for all models except Model S. This is likely due to Profit's comprehensive fitting of previous results and its consideration of multiple dimensions in the analysis. Despite a significant drop in sales in 2023, the model suggests a high potential for sales recovery in the future based on earlier trends. And for Model S, which has had relatively stable sales, Profit still captures the likelihood of a future decline. This is reasonable, as the Model S is one of the earliest models released and is likely to face competition from newer models, resulting in a long-term downward trend in sales. However, Profit has its own limitations. It can struggle with complex non-stationary series. Additionally, due to our limited sample size, we couldn't allocate more data to the training set, which affect the quality of the fitting. And given the complexity of the factors influencing sales, both internal and external systematic risk, we can choose a theoretically more suitable model for forecasting on one hand, while machine learning approaches may perform better in handling such black box problems on the other hand.
Finally, I will wrap up with a summary, including insights from the forecast results and comments on the forecasting methods. Overall, while there have been some periods of underperformance in recent years, Tesla's sales trend is generally upward. With a growing awareness of sustainability, the future outlook for the electric vehicle market is promising. There may be some unexpected factors that could impact short-term growth, but according to our forecasts, sales are expected to rise in the future, particularly with new model releases. Companies can plan their production lines in advance, utilize resource efficiency, and establish a risk management system. In the long term, however, this growth trend will likely stabilize, as demand is not infinite. Our forecasting methods also have some limitations. There are many factors influencing sales, so we are not choose to use traditional regression models to avoid omitting variables. Maybe using machine learning tools like random forest and XGBoost to identify correlations and patterns in the data may improve the accuracy of predictions. That's what I have tried. So that's all. Thank you.